Hi everyone, let's solve this logarithmic equation. Log base 5 of the log base 125 of x equals the log base 125 of the log base 5 of x. Go ahead and pause the video and give it a try. So there are undoubtedly many ways to solve this equation. When I look at it, the first thing I notice is the logarithm on the left-hand side has a base 5, and the logarithm on the right-hand side has a base 125, which is a power of 5. It would be nice if we could adjust the bases so that they were equal. Well, we can do that. We can change the log base 5 into a log base 125 by using a little known property of logarithms, which states that if you have a log base b of a, then you can raise the base to any power you want and the input to the same power, and the resulting logarithm has the same value. For example, the log base 2 of 4 is equal to 2, and if I, let's say, cube the base, 2 cubed makes 8, and if I cube the input, 4 cubed makes 64, it's still 2. These are equal logarithms. So I'll leave it to you to prove this property if you're interested. So here's how we can apply it in this case. I'm going to take this logarithm base 5 of the log base 125 of x, and I'm going to cube the base as well as this entire input. And we find out that that is the log base 125 of the log base 125 of x all cubed. So again, I just cubed the base and cubed that entire input, making use of this formula. All right, so that's the left-hand side. And now if you compare that with the right-hand side, you'll see the right-hand side of the given equation is also a log base 125. So if these logarithms with the same base are to be equal, that would imply that their inputs that I'm underlining have to be equal. So we can reduce the given equation to the following. So the log base 125 of x all cubed, which is what I'm underlining here, must equal what I underlined at the top here, log base 5 of x. So that's a simpler equation than the one we started with, but we can actually apply that same formula again to the logarithm on the right. I would like that to have the same base of 125 that I see on the left. So I'm going to cube this base and this input. So we get the log base 125 of x cubed equals the log base 125 of x cubed, like that. Okay, so when I look at this equation, now it looks much more promising, much easier to solve because I have the same base logarithms, only one on each side. I'm going to use a common property that all algebra students do know about, which is that the logarithm on the right-hand side can be written as 3 times the log base 125 of x. So now I see the log base 125 of x appearing in 2 different places. Let's rename that. Let's let y equal the log base 125 of x. Well, then this equation we're trying to solve becomes y cubed equals 3y. Well, that's easily solved. Let's subtract 3y from both sides and factor out a y. And this implies that either y is 0, or the positive square root of 3, or the negative square root of 3. Now, two of these can be ruled out immediately. Remember what y is. Y is equal to the log base 125 of x. But if we look at the original equation given to us, on the left-hand side, we see that the log base 125 of x, or in other words, y, is being used as an input to this logarithm base 5. Well, an input to a logarithm must be a positive number. It can't be negative, it can't be 0. So these are not possible answers for y. So that leaves just the square root of 3. So we have the log base 125 of x is the square root of 3, and that implies that x is equal to 125 to the power square root of 3. Okay, and that is the only solution of the equation, and I'll leave it to you to make a check of that solution, try substituting it in and verifying that it is indeed correct. All right, thanks for watching the video.